Hey, hello, welcome. So today we are going to discuss about text classification with ML.NET. This is the main concept, and how is it related to Blue Prism? So there is a wild thought that we were thinking about. ML.NET is a proven framework on top of machine learning, so which was built and maintained by Microsoft since long back. So we will try to do some implementations with ML.NET, and after that, is it possible to integrate this MLNet with Blue Prism? That is the experiment that we are going to do. Maybe not today, but we will do it maybe in the next session. But today's session, the main agenda would be, so what is ML.NET, and of course in short we'll call it as MLNet, and what is AutoML model builder, and also the tools which are required to implement MLNet models, or maybe implementing or maybe developing machine learning models with the help of .NET framework and also Visual Studio. The tools which are required, and we will have a short demo on that. Yeah, let's get started. So what is MLNet, or maybe ML.NET? So ML.NET built for .NET developers basically, and it's a proven technology. Why? Because since long back, Microsoft has internally using this ML.NET for their internal purposes. Like you might have seen an application called Microsoft Office, which was there since long back. So within this MS Office, what everybody is trying to do, usually, we will start preparing Word documents, or maybe presentation PPT, and also spreadsheets, etc., etc. How this ML.NET is got used inside this MS Office? Okay, there is a question. When you try to write or maybe type something into your Word document, it used to give some kind of intelligence, or maybe the sentence formation intelligence, or maybe spell correction. All these things are getting done by the help of machine learning. Okay, these things will be will be done with the help of MLNet. That is the reason I'm saying this was proven technology. This is not at all a new framework or new technology from Microsoft. It was very old. However, Microsoft internally uses it for their Office products. Now they realized, and this can help .NET developers to cross train themselves in terms of machine learning models and all. That is the reason they have open sourced it, and it is openly available in the open source world. Anybody can use ML.NET who are having the basic knowledge of C sharp or F sharp or whatever it is. So the main target of MLNet, uh, it is created to help .NET developers so that they can getting started with machine learning models. ML.NET lets you reuse all the knowledge, skills, code, and libraries you already have as a .NET developer, so that you can easily integrate machine learning into your web, mobile, desktop, games, and IoT apps. So that is the advantage. And typically, the .NET uh, platform, we already know about it, and everybody uh, you know um, good at understanding this. And I hope you already know Blue Prism is based on .NET. Okay, and we know how to code, basic code stages, etc. However, you have an option of using C sharp or VB.NET. If you are good at C sharp, if you know how to use existing libraries, you know how to build a library, why can't we create a machine learning model with the help of ML.NET? And why can't we use it as part of our Blue Prism process? So that is the wild thought that we got, and we started doing some kind of experiments on it. Maybe we may get succeeded or we may not, but no, just uh, trying something interesting is not going to hamper anything. End of the day, what will happen, we will learn something. So we wanted to introduce machine learning with the help of MLNet, so that you can easily integrate machine learning models to the Blue Prism. That is the motto of this experiment. But before moving to that experiment, we just wanted to give an introduction to how can we understand ML.NET and how can we getting started with MLNet. So that is the reason we created this session. And and next point, what is AutoML model builder? Okay, so first part, what is MLNet, and the second part, what is AutoML? It seems like interesting, and if you guys ask me, this is bit relevant to automation. Okay, so previously anybody wanted to implement kind of machine learning, we need a data scientist. And what a data scientist typically do, he will try to use he will try to collect some kind of uh, algorithms based on the data that he get, and based on that data and algorithms, what he will do is he will try to apply the same data on top of each algorithm, and he will identify which one is trying to give good result. Like if I have given, think about OCR. Okay, if you have an OCR requirement where you need to read some text, maybe handwritten text from a document. Consider you have number 8, which was written with the help of a pen. Okay, and you have given it to ML model. And what ML model will typically do is, or maybe ML process will typically do is, they will try to apply multiple algorithms to identify this particular image is associated to number 8 or not. Okay, and they will start experimenting with multiple algorithms. Whatever the algorithm is trying to give the more accuracy, like about above 80 percentage, 90 percentage of the accuracy, then we will call it as the good model, or maybe the best fit model for this kind of text. So this is the basic implementation everybody used to do, in terms of machine learning. And these data scientists will try to experiment with multiple algorithms which are relevant to the data. It's not like blindfold, but they will identify the relevancy, and based on that they will pick and choose a few algorithms, and they'll try with different algorithms. And then what next? So nowadays, based on the result that they have got, simply they will fit a model, and they'll say this is the best model, so that end user can use it. That is how usually the typical ML thing used to work. Of course, internally they used to do a lot of operations. They used to reduce the error, blah blah blah. There were a lot of terminology. Actually, a lot of implementations that uh, data scientists will do. Of course, as I'm not a data scientist, I usually don't worry about those things, because those are most important. Again, it will go bounce if we try to discuss more about all those things. Now, the concept is AutoML. Why AutoML? What is the meaning of AutoML? If we just wanted to understand about AutoML, we have some relevancy over here. ML.NET offers Model Builder, a simple UI tool, and MLNet CLI to make it super easy to build custom models. So if you wanted to build a custom model, we have something called Model Builder. It's a UI tool which is part of Visual Studio that will help you to create models. Now, what it will do internally, these tool these tools use automated ML, or in short, they'll be calling it as AutoML, cutting edge technology that automates the process of building best performing models for your machine learning scenario. This seems a bit interesting. How, something like machine learning can be automated. So that is where they started this automated ML. What typically it will do is, it will simply collects all the related machine learning algorithms based on the data that you have selected, and it will start executing all the algorithms automatically. you know Again, it's automation, automating the machine learning model. Automating the machine learning development is called as AutoML. That is one of the you know upcoming trendy technology that all the big force are running behind. If this is going to implemented as per the standards, definitely in near future we may uh, lose a role called data scientist, because technically speaking, data scientist is not required to build a machine learning model. However, their thought process is required to guide data engineer to build a machine learning model. Okay, that is always there. Okay, replacement means it is going to replace the role, but not the thought process. If one can think in ML way, he can guide five data engineers to build more productive uh, ML algorithms. So that is what the story behind automated ML or AutoML. Okay, so this is the main important thing about this AutoML. I am not a data scientist. I don't know how to build machine learning models, but I know the concept called AutoML, or maybe automated ML, and how to use it with the ML.NET. So that is what I know. So let's try experimenting it with the Visual Studio. If we can implement a machine learning model from scratch with the help of automated ML, and also the model builder tool that Microsoft has provided, so we can do something interesting. And my thought is, if we can implement this, why can't we integrate it with our Blue Prism? That is the question. Okay. Anyways, we will see the tools that are required for developing machine learning models with MLNet is Visual Studio, and you should know C Sharp, and we need ML.NET libraries. And if anybody wanted to know more about MLNet, there is a reference link here in the bottom of the slide. It is .NET Microsoft.com/apps/machine learning hyphen AI slash ML hyphen .NET. Okay, so this will gives you more information about AutoML or maybe MLNet, and how to getting started, etc. Now it's time for demo. I'm jumping to my other screen. So I have my Visual Studio. I will try to create a new application. I'll take console application. I would like to name it as AutoML demo. And by default, I'm taking .NET 5 as my default .NET target framework. So Visual Studio started, and I have a very simple program, says hello world. Maybe I would say hello MLNet. Just try to run it, whether it is getting executed or not, to make sure the things are working as expected. It is getting built. There you go. It got executed and it is saying hello MLNet. Okay, and yeah, we are good. So the application is running as expected. Now it's time to jump to AutoML. Okay, right click on the project, select add. Within the add, you should be able to see machine learning. However, before moving to the machine learning, you should follow the link that I have provided. Like you can visit that page to install machine learning model builder. uh, you should be enabling it while installing your Visual Studio. It can be Visual Studio 2019 or maybe 2022 preview, whatever it is. You can use any of these, but you should install appropriate machine learning, model builder. And also you need to enable the feature called machine learning. Within the environment, what you need to do is you need to select the tools, options. We have environment. Under the environment, we have a preview feature. Select the preview feature, and you should be able to see enable MLNet model builder, which might be unchecked, but you need to check it. Okay, this setting has to be done by you if you already not done. Okay, we need to check this. Click OK, and then you should be able to see machine learning. Okay, I'm going to select machine learning over here. When I have selected machine learning, it will simply redirects me to add new item, and here it is showing as machine learning model ml.net, exactly over here. You can give a name, ML model. Okay, it just given us some default name. I'll give a demo ML model as my name. This is going to be my machine learning model name. I'll say add. There you go. So actually what it is trying to do, it just simply opened a wizard kind of look and feel, where you can directly select, pick and choose your machine learning uh, machine learning problem type that you just wanted to deal with. Okay, so here we have different types of options like text classification, value prediction, image classification, recommendation, object detection, blah blah blah. But as a simple implementation, I would like to go with text classification, so that it's basically an NLP problem, and kind of low hanging fruit. Let's start with text classification. I have selected text classification, and I would like to use my local CPU to train my model. And this is my processor and memory. Basically, these things might be different in your system based on your system configuration. And select next, and it will try to ask from where you just wanted to pick your data. Okay, either you can choose file system, or maybe you can choose SQL server. Both are possible. And I have downloaded some open source data set, openly available data set. This is associated to spam text. Okay, so I'll open one of the CSV. Okay, basically if you wanted to understand the data, it is important to know the basic things. Okay, whenever you try to deal with machine learning model, it's always important to understand what all are the things are involved, or maybe terminology involved in machine learning. Okay, basically what things that you need is you need something called label, and also you need something called feature. What is this label and feature? This is machine learning terminology. And features which are affect your predictions, or maybe which are affect your result, will be called as feature, and the result is going to be called as label. Consider you have this particular text. You don't know how stubborn I am. I don't even want to go to the hospital. I kept telling Mark, I am not a weak sucker. Okay, hospitals are for weak suckers. Okay, this is a sentence, or maybe this is a message was received by a particular user. And if you try to read it properly, it is saying, this is some kind of text. And the result of this text, of course, if you a normal user, when you have seen this message, obviously you can understand whether it is a spam or not. Okay, obviously spam messages are highlighted as a spam, the category given as a spam. And if it is not spam, just mentioned as ham. To just represent it in numerical format, we have categorized it with the help of zeros and ones. If it is a spam, we have marked it as 0. If it is not spam, we have marked it as 1. So I'm just thinking, this is going to be my label. I want this result. If I have given this text, I'm expecting this result. Okay, the input values that we are about to give will be called as features. The output that we are expecting will be called as label. This is data science terminology. Okay, if the input will get affect, or maybe input is tightly coupled with the help of more than one column. Maybe I have another example to show. We have something called, yeah, I have something called corona NLP, some data. Okay, if you try to see, these are the tweets which were collected based on a particular keyword. Okay, so this is corona data, and the tweets that are tweeted by multiple users, and by multiple locations, and the date that they have tweeted. If you try to see, this is the technically this is the label. Okay, and you can pick and choose multiple features which will affect the sentiment, or maybe which will affect the label. Okay, so consider a particular guy is there, a particular guy tweeted like this, and he is in the New York City. Maybe if these two are related, if the value is getting changed, we can consider these two as our features. Of course, this is going to be confuse you a bit to understand what is feature and what is label. In short, if you ask me, features are going to be inputs that you will give to a machine learning model, and label is going to be your expectation, what you are expecting as a output from a machine learning model. However, to train the model, you need both. Like, you should have input, you should have output. That is where all the input fields will be called as features, and all the output result that you are expecting will be called as label, in short. Okay, I hope it makes sense, but always you can question. I'm happy to give more details on that. Of course, we do have internet within our hand. You can always understand the detailed information about what is feature and what is label. So here I just wanted to pick my message as my feature, and label column is going to be my label column. This is what I'm expecting as my output. Now I will go and give it as my input over here because I have selected the file CSV as my data source, and I will move to yeah. So we have sample data set. Okay, I'd like to take a training data set. See, whenever I have selected this training data set, it just picked all the information from the spreadsheet and it has given us some basic details about the data. Like uh, we have total 5,526 rows in the given spreadsheet and all three columns, okay, including 0 columns that are ignored. Right now it have picked everything. However, it is showing only top 10 of 5,526 rows. Now column 2 predict, that is nothing but label, which column you wanted to select as your label column. Anyways, I intentionally named it as label column. I have picked my label column, and advanced options, if you try to see, we have category, and I mean, this is the feature. Category is feature and message is also a feature for me because this is my important feature. Now I will click on save. That's okay. Ignore that message. And you can simply click on next step. We'll see. And in the next step, this is the training section. Within the training section, what it is trying to tell, how much time you want to execute this training model, how much time that you would like to train this model. Maybe I have given 10 seconds and I'll click on start training. Let's see what it started doing it. See, it started executing multiple machine learning algorithms. These all are the machine learning algorithms it try to execute and try to see. In the first ML model, the accuracy is 86. Okay, we'll move to the one by one. In the first model, the accuracy is 0.8686. Okay, and the duration it took is 1.6 second. And the second is also the same, took the same time. However, second time the duration is 0.5 second. Likewise, it tried to experiment with multiple ML algorithms to come up with the best model. Okay, so these all are the I mean, it tried 13 times, 13 iterations. We will be calling it as 13 iterations. Sometimes it might have used the same algorithm with the different permutation combinations. So that is where you can see the same algorithm name multiple times to understand or maybe to estimate the best algorithm. Okay, the summary, it just ML task is classification, and this is the data, input data, and this is the label. Label is the label column. Total experiment time is 8.37 seconds. Total number of models explored 13 models. And if you try to see, top 5 models explored. Okay, so it is giving fast forest OVE algorithm, and it is at 12th iteration. If you try to see the accuracy, it just given 100% accuracy. The duration is 0.6 second, and LBFGS maximum entropy multiple algorithm. I mean, if you are a data scientist, you might be familiarized with this. I'm not a data scientist, so I don't know all these things, but this is related to classification problem. Obviously, AutoML has picked all these algorithms automatically, and it just given us some output. And if you try to see, automatically automated ML has identified this particular thing as our best algorithm for our problem, because it has just given us one I mean 100% accuracy with 1.1 duration and the iteration number 14. Then what it did was it started generating the code behind files. Okay, it just copied the files in the same folder that I have created my project, and updating Nugget dependencies because it needs some Nugget dependencies like Microsoft.ml, Microsoft.ml, faster tree. See, all these libraries were required to execute the code. Okay, that is where it just added this code. And you might have asked me, why should we give only 10? Okay, no, it is not restricted. Simply you can increase the time to get the maximum time. And as I'm using some kind of sample data, it just started giving very good numbers like above 80 percentage. Usually sometimes you will see 10 percentage, 15 percentage of the accuracy. In the time you might required more time to experiment with multiple algorithms. That time even you can give 60 seconds, 120 seconds, or maybe 300 seconds, whatever is suits to you. Okay, so it is always based on your input. If you can increase the time, your accuracy may go up. Okay, if it is not actually performing well, try to increase the time and train your model accordingly. Okay, and what next? Of course, we do have a next button. Click on next, and it usually used to ask for some inputs. Okay, the category is ham, and you have just given some text. I mean, technically ham is not a spam. Let's see. It is saying result is 1. 1 means 1 is not spam, 0 is spam. Okay, the model is telling, I am 100% sure this is not a spam message. You don't know how stubborn I am. I don't even want to go to the hospital, blah blah blah, whatever it is. Okay, so that is the message that we have. And if we wanted to experiment, maybe we can experiment with some other text. I have just actually exported the text in, I mean, I have taken some additional examples which are not part of training data set. Okay, so this is actually not spam. We will see how it will perform. I have just given this as my input. Of course, it just predicted as yes, it is not a spam. Okay, and yeah, let's jump to the next step. It had just given me some inputs. Let's copy the code, jump back to the program .cs file, paste it. See, we have demo ml model input is expecting two features. That is nothing but our input parameters. One is category, another one is message. You are responsible to pass these two features to your ml model. ML model will predict the result, so you will get result and you can print your result. Okay, now I will try to print my result. Right line, so result dot prediction. Okay, now try to execute it, how it will perform. Right, so it has just given the prediction as 1, means this is not a spam. This is not a spam basically. Now I will try to give some spam text and verify whether it is going to identify it as a spam or not. These two are the inputs. I saved it and tried to execute it. See, it just given it the output, the prediction as 0 means it's a spam. Okay, so basically I just wanted to conclude it as text classification with ml.net. And if you wanted to understand what all are the components were there, you can directly see. I mean, model builder has directly generated the default classes like demo ml model consumption and training. So what basically it will do is it will create builder build pipeline, and here it is trying to read the category and message from the uh, input that we have provided, and based on that it will try to I mean, these two are the features, because features are category and message, and our label column is going to be label column. Once this is done, it will try to execute the pipeline based on this. The model will get created, and that model will be stored in the same bin folder with the help of .zip. We have given our project name as I mean, our model builder name as demo ml model. So it has just created demo ml model.zip file, so that I can use my machine learning model in the further sections wherever required. Technically, this is my machine learning model, and I know how to use it with the help of C sharp. Then what are we waiting for? Okay, so what we can do is simply, if possible, we can directly, yeah, we can create a code stage where it will take category as input, and I mean, message body as input, and prediction will be sent over here. And how much code that we need to create it? We need input body, category, output is going to be my result, that is nothing but predictions, and this is the code, same code. Okay, same code that can be utilized over here. Okay, and ml model one dot predict, here we need to write my ml model name, and this should be capable of predicting the machine learning. I mean, it should be capable of predicting my uh, input body was a spam or not a spam. Okay, that is where we have taken this example. And if you try to ask me whether this is got implemented or not, no, this is not yet implemented. We were experimenting with the MLNet. If this is got done completely, probably we will have another session to how to use MLNet within your Blue Prism. So that is going to be our next session. Uh, Stay tuned for the interesting topics, and thanks for watching. Please try to subscribe if you feel I mean, the inputs that we are trying to give are helpful for you, and feel free to give your feedback. Thanks for watching. Have a great day.